Hello and welcome back to Universe Sandbox, the only game that shows you how cool space is. I have no idea what I want to do in this video other than mess with space, because space is cool. That's why that's the title of the video. I don't know why I'm just doing this back and forth on the Earth. I'm sorry if that bothered some of you. And also sorry that this video is late and that I haven't been uploading twice a week like I said I would normally a while ago. Stuff happened. I got stressed. And then I forgot. I already know a main thing I want to play with. Oh, they changed this. That's cool. Main thing I want to play with is just the Roche limit. That's just, I don't know why, it's just one of the coolest things to me, even though I understand it. There it goes. As that's gonna just destroy the planet. So sorry if you live across like the equatorial region, and I hope that does not eat my house. Okay, to miss like my half of the country. Okay, so sucks to be in this part of the US. I mean, we're only moving at 5 minutes a second. What's the orbital speed of this thing? 30 kilometers a second, essentially. Wow. Whoa. The impacts actually like take out hunks of the atmosphere. That is cool. Basically Roche limit, what it essentially is that the tidal and gravitational forces exerted on two objects at its extremist. Obviously the thing that holds the Earth around the sun, that holds Mercury around the Earth and the Earth around the sun and the sun around the center of the galaxy, is a magical the invisible force of gravity. Every single thing with mass has gravity, because the way space-time works is that space is a giant fabric, and that anything with mass disturbs that fabric, and we feel that is the invisible force of gravity. So the bigger the curve, the stronger the gravitational pull essentially is. So the closer you are to an object, like say the Earth, the deeper the curve than say out here. That's why objects closer in move faster than objects further out. The gravity is obviously much weaker. Right here, this side of Mercury, the Earth is pulling on this part of Mercury harder than this side, because this side is facing the Earth, this side is facing away. Makes sense. Normally with something like the moon, which would be probably about here, 500,000 miles away, and then it's probably only a few, it's not really noticeable. And the moon is doing it back. That's what creates the tides. So what happens is the moon's gravity, for as far away as it is, and how weak the gravity actually is, it's like a sixth of Earth's, is able to pull the oceans up off of the Earth a little bit and toward the moon. And as the Earth spins, that rushes onto land, creating a high tide, and then as the Earth continues to spin, that is low tide as the water goes back. But for the same reason, that's also slowing down the Earth's spin a tiny bit, because I was exerting a force on the Earth. I don't know why I paused the game. I was exerting a tiny force on the Earth, where about every 1,000 years or so, I think, the moon's gravity slows its rotation by about 2 milliseconds, so barely anything. But here's the interesting thing. The Earth is spinning faster than the moon is orbiting the Earth, so the tidal bulge that the moon is creating sits slightly ahead of the moon. So that creates a little bit of, I don't know what the right word is, but it essentially repels the moon a tiny bit away from the Earth every year. It's not that much, it's like 1.5 inches a year. But since Mercury is extremely close, the forces are much stronger. I think the Roche limit around Earth is 11,000 miles above the surface, somewhere around there. The Earth is tugging on one half of Mercury so hard that it's able to physically grab hunks of rock off of the surface and split into space. I guess I could use a black hole, because black holes are cool. Damn, why didn't I throw a black hole through the solar system? I'll probably do that later. Where's the sun? Boop. Oh, why did I grab the biggest black hole in like a tiny star? This star looks tiny. How big is this star? radius. 4.13 suns. And that's actually not that far. 21. I know there was this huge star. Where is it? VY Cosmic Universe? It was this one. UV Scouty. This makes the black hole look absolutely tiny. The black hole has a radius of 1.2 astronomical units, or about a quarter of the Earth's distance to the Sun. That's one astronomical unit. The distance between the Earth and the Sun, which is 93 point something million miles. And this star is why am I not clicking on you? I want to see the information about you. And you're making me. Oh, this star has a radius of about 8 astronomical units. I'm just gonna slow down time. Because black holes are black holes and do whatever they want. What? What just happened? Why is the star now like 2 astronomical units wider and like, is that 700,000? Why does it have the mass of like 7 million suns? Where's the black hole? Why'd the black hole lose so much mass? Okay. What? Why? 2.44 light speed. What? No, first of all, it's physically impossible for things to move through space faster than the speed of light. However, space can do whatever the hell it wants and move faster than the speed of light if it wants to. However, that's just a discussion for another day. But still, what just happened? Why did it happen? Almost now, absolute zero. What happens if I just... I'm too lazy to type a zero, so I'll just do a negative sign to make it go backward. Whoa. I don't think that's how speed works. 4.2 second and 4.2 days a second. Yes. Basically, if two objects are hit each other, their speed will obviously differ. So if one thing's moving, say 10 kilometers a second left to right, and something hits it at the same speed but right to left, theoretically the speed would cancel out since negative forces. But if something's going only about 2 light speed, where did this extra 28 light speed come from? It's like, hang on, I forgot something from the store. I'll be back in about a few million years. Thanks, gotcha. Andromeda and Milky Way galaxy collisions. About 4 billion years from now, our Milky Way galaxy will collide with the nearby Andromeda galaxy. This collision, the result of the mutual gravitational attraction between the stars, planets, and other matter that make up both galaxies, will produce a single merged galaxy. It is unlikely that any stars in the galaxies will actually collide, although some stars will likely be ejected from the combined galaxy during the merge. Basically, black holes like each other. Then they'll be like, hey, wanna be friends for like until all of our stars die, and then we're undetectable by normal means. Like, hell yeah, let's go. Wow, we have to move in 1,000,000 years a second and this still looks slow. Fun fact, our galaxy is in the process of destroying, well, I believe to be destroying 2 other galaxies. I can't remember the name, but there's like 2 small galaxies like orbiting ours, and it's like orbit is passing through. It's like passing between some of the arms. On March 27th, 2020, astronomers using the WISE Space Telescope for a near-Earth object search called NEOWISE discovered a previously unknown comet, later designated C/2020 F3, also known as Comet NEOWISE. It made its closest approach to the Sun on July 3rd and its closest approach to Earth on July 23rd. Comet NEOWISE increased in brightness as it approached the Sun, becoming visible to the naked eye. For most of July 2020, the comet is now fading again as it moves away from the Sun, not to return for thousands of years. Wow. So this was literally a once-in-a-lifetime opportunity, and I don't think I saw it. I probably did. So basically what's going to happen is it's going to whip right past the Sun, get a ton of momentum, like about, I don't know, 80 kilometers a second, probably more like 100. About 77. Get flung by, but it's moving way too fast for the gravity to slow it down, and it begins to approach the Earth about, oh, I missed it. And then it begins to fade back into the darkness, and this is its orbit. Wow. So basically, it uses the momentum it gained from its close approach to the sun, but as it flies away, it loses a ton of momentum. And as it begins to move slower, 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 slower. Yeah, it's beginning to gain speed, but okay, so yeah, we almost finished a full orbit. What is the orbit on this thing? 11,000 super years. 4,949 years. And obviously, as it moves closer to the sun, it begins to move faster. And the exact same thing will happen again. It will pass right. I just realized it's moving at 3 years a second. Going to get really close to the sun, get a ton of speed, then they're gonna pass all over the planet and get flung back out to be gone for a while. What else could I do? I can mess with binary orbits where they tear each other apart. Let's go with Earth. That's the thing I had selected. Binary balance motion on, sure. Binary basically means they orbit each other. The center of gravity is not in the middle. Normally in a planet, it's like the center of gravity is in the middle of the planet, but now like more in the middle between the two. Decrease the speed so they fall closer. Ooh. It didn't really startle me. Wow. Was not expecting that one. I think that's a good place to end off this video here. If you enjoyed this video at any point, be sure to hit that like button. Subscribe if you haven't been new to my channel, and change notification settings to all so you always know when I upload my next video. Sorry for the, this video being late. Stuff happened, not my fault. I was stressing about it. I think I got the most stressful thing off my chest, so that's good. Only 2 people know what I'm talking about besides myself. I'll see you guys in the next video. Peace.